Forecasting, using weighted moving average, a tutorial. Hello, today we will explore forecasting using the weighted moving average. Please refer to the provided Excel datasheet. The sheet contains columns A through column H, and I column A represents the independent variable, time or X, ranging from 1 to 10. We will forecast the value for time 11, specifically April 14, 2025. Column B contains dates from February 3 to April 7, 2025. Our goal is to forecast bike sales for April 14, 2025, using the weighted moving average method. In this example, we'll assign the following weights: 40% to the most recent observation on April 7, 2025, with 43 bikes sold, 30% to the previous observation, 41 bikes, 20% to the one before that, 38 bikes, and 10% to the oldest observation in our set, 34 bikes. Unlike a simple moving average, which gives equal weight to all data points, a weighted moving average prioritizes recent data. This makes it more responsive to current trends. This approach is particularly useful in fields like finance, where recent price fluctuations are often more indicative of future trends than older data. Manual calculation. To manually calculate the weighted moving average, enter an equal sign, equals, in the desired cell. Then, click on the most recent weight, 40%, and press F4 to lock the cell reference, making it absolute. Multiply this by the corresponding data point, 43 bikes. Repeat this process for the other weights and data points, 30% times 41, 20% times 38, 10% times 34. Sum the results and press enter. Then, drag the cell down to apply the formula to the rest of the column. Using SumProduct. A more efficient method is to use the SumProduct function. Type equals SumProduct in a cell, then highlight the weight cells and press F4 to lock them. Next, highlight the corresponding bike sales data. Close the parenthesis and press enter. Drag the cell down to apply the formula, extending it to time 11, date April 14, 2025, which yields a forecast of 64.90 bikes. Evaluating forecasting performance. To assess the accuracy of our forecast, we'll examine error metrics such as mean absolute deviation or MAD, mean absolute percentage error or MAPE, mean squared error MSE, and root mean squared error or RMSE. Evaluating forecasting performance. To assess the accuracy of our forecast, we'll examine error metrics such as mean absolute deviation or MAD, mean absolute percentage error or MAPE, mean squared error MSE, and root mean squared error or RMSE, MAD or mean absolute deviation. This measures the average magnitude of errors, ignoring their direction. It's calculated by averaging the absolute differences between predicted and actual values. MAD provides a straightforward measure of the average error. MAPE or mean absolute percentage error. This expresses the average error as a percentage of the actual values, making it easier to compare accuracy across different datasets. It provides a relative measure of error, useful for comparing models. MSE or mean squared error. This calculates the average of the squared differences between predicted and actual values. It penalizes larger errors more heavily. O performance, sensitive to outliers, measures overall error variance, less intuitive due to squared units, useful when large errors are critical. RMSE or root mean squared error. This is the square root of MSE, bringing the error metric back to the original units, making it easier to interpret. Calculating error metrics in Excel. 1. Error calculation. Calculate the error by subtracting the forecast from the actual value equals actual, forecast. Drag the formula down. 2. Absolute error. Use the ABS function to find the absolute value of the errors. Drag the formula down. 3. MAD calculation. Use the average function to calculate the average of the absolute errors. 4. Percentage error. Divide the absolute error by the actual value. Drag the formula down. 5. MAPE calculation. Use the average function to calculate the average of the percentage errors. Format the cell as a percentage using Ctrl plus Shift plus % or the Format Cells dialog box. 6. Squared error. Square the error values. Drag the formula down. 7. MSE calculation. Use the average function to calculate the average of the squared errors. 8. RMSE calculation. Use the SQRT function to find the square root of the MSE. Comparing forecasting models. The Excel sheet highlights the forecast values in yellow and the calculated error metrics in green. To evaluate the effectiveness of the weighted moving average, compare these metrics with those obtained from other forecasting models, such as trend regression or simple moving average. The model with the smallest error metrics is generally considered the most accurate. This comparison will enable you to select the best forecasting model for your specific data. Thank you, and I look forward to our next session.